Welcome back to Learn Civil Easy. In our last two lessons, we learned how roads are classified first by location and function, then inside a city by function and access control. Today, we look at something you can actually see from the sky, the shape of the network itself, road patterns. Look at these two Indian cities from above. On the left, Chandigarh, straight roads crossing at right angles, dividing the city into neat rectangular blocks almost like a chessboard. On the right, Connaught Place in New Delhi. Circular roads one inside another with straight roads shooting outward from the center like the spokes of a wheel. Both are cities, both are roads, but the shape of the network is completely different. That shape has a name. It is called the road pattern, and it is chosen deliberately by a planning engineer long before the first road is built. A road pattern is simply the geometric layout of a road network, the arrangement of the roads over the area they serve. Now, why should we care? Because the pattern decides three things: how far people have to travel to get anywhere, how easily traffic can move and turn at junctions, and how simply the town can grow tomorrow without tearing up what was built today. Choose the pattern badly, and the city lives with that mistake for 100 years. So let us meet the six patterns. There are six standard road patterns: rectangular or block, radial or star and block, radial or star and circular, radial or star and grid, hexagonal, and minimum travel. Notice that three of the six are radial patterns. They differ only in what fills the space between the radial roads. Keep that in mind, and the whole list becomes easy to remember. Let us take them one at a time. First, the rectangular or block pattern. The whole area is divided by two sets of roads crossing each other at right angles, forming rectangular blocks. This is the simplest pattern of all. It is easy to survey, easy to set out, easy to divide into plots, and easy to extend at the edges. The city roads of Chandigarh follow this pattern, but watch what happens when someone wants to travel diagonally. There is no diagonal road, so the journey becomes a zigzag along two sides of every rectangle, and the distance traveled goes up. There is a second problem too. Every junction here is a four-arm crossing, and a four-arm crossing has the largest number of conflict points. So from the point of view of traffic operation, this pattern is not considered convenient. Second, the radial or star and block pattern. Here we start from a central point. The business district and roads radiate outward from it in every direction like a star. The space between those radial roads is then developed on the block pattern, so it is a hybrid: radial roads for the long journeys into and out of the center, and rectangular blocks for the local streets in between. The advantage is direct access to the center from every direction. The difficulty is that every one of those radial roads delivers its traffic to the same central point, so the center becomes congested. Third, the radial or star and circular pattern. Again, the roads radiate outward from the center, but now they are tied together by circular roads, laid one inside another around that center. We call these ring roads, and that single addition solves the problem we just met. A vehicle that only wants to pass from one side of the city to the other no longer has to drive through the middle. It joins a ring road, travels around, and leaves on the radial it needs. The center is relieved. The road network of Connaught Place in New Delhi is an example of this pattern. The price you pay is at the junctions where a radial road meets a ring road. The intersection becomes complicated. Fourth, and this is the one to pay attention to, the radial or star and grid pattern. Start with a group of villages, connect them to the town that serves them, and you have made a small star with the town as the focal point. Now do the same thing one level up. Connect those towns to the district headquarters or the state capital, and you get a bigger star drawn over the first one. Keep going, and the whole country is covered on an expanding scale. Every village reaching its town, every town reaching its capital. That is the beauty of this pattern, and here is why it matters for your exam. The Nagpur Road Plan Formulae. The first 20-year road development plan, which you have already studied, were prepared assuming exactly this star and grid pattern. So this is not just a shape on a page. It is the shape the Indian road network was planned around. Fifth, the hexagonal pattern. Here, the area is divided into hexagonal cells like a honeycomb, and the roads run along the sides of those hexagons. Look closely at a junction. Only three roads meet at each node, never four. And that is the whole point of this pattern. A three-arm junction has far fewer conflict points than a four-arm crossing, so traffic movement is safer and simpler to control. The disadvantage is that there is no straight-through route anywhere in the network. Every journey bends around the cells, so travel distances increase, and the plots left between the roads are awkward to build on. And sixth, the minimum travel pattern. This one is not designed around a geometric shape at all. It is designed around a target that the total distance traveled by everyone in the city should be as small as possible. So we begin with the city center. Around it, we place sector centers, then suburban centers, then neighborhood centers, and then we connect each level to the next by the shortest practical route. The network that results looks irregular, almost organic, but every road in it is earning its place. The advantage is obvious: minimum travel. The difficulty is equally obvious. It is complex to plan and almost impossible to impose on a city that has already grown. So, which pattern should you use? There is no single right answer, and your exam will not ask you for one. Each of these patterns has its own advantages and its own limitations, and there can be many other geometric patterns besides these six. The choice depends on the locality, its terrain, and its shape. It depends on the layout of the towns and villages already there. It depends on where the industrial and production centers sit. And finally, it depends on the judgment of the planning engineer. Remember that last one. It is a mark, and most students forget it. Let us put them side by side. Rectangular right angle crossings, simplest to layout, but zigzag diagonal travel and four-arm junctions. Chandigarh, radial and block, direct access to the center, but the center gets congested. Radial and circular ring roads relieve that center at the cost of complicated junctions. Connaught Place, radial star and grid, expands outward level by level, and it is the pattern behind the Nagpur road plan. Hexagonal, only three roads at a node, so fewer conflict points, but no straight route anywhere. And minimum travel, the shortest total travel distance, but the hardest to plan. Before we close, the questions that actually get asked. 1. Explain the various road patterns with neat sketches. Draw all six. The sketches carry the marks. 2. Which road pattern was assumed while preparing the Nagpur road plan formulae? Star and grid. 3. Give an Indian example of the rectangular pattern and of the radial and circular pattern. Chandigarh and Connaught Place in New Delhi. And 4. On what factors does the choice of a road pattern depend? Locality, layout of towns and villages, industrial and production centers, and the choice of the planning engineer. So, 6 patterns: rectangular, radial and block, radial and circular, radial star and grid, hexagonal and minimum travel. 3 of them are radial, remember that, and the list stays with you. The study notes and the MCQ practice paper for this topic are waiting on our Telegram channel. The link is below. Next time we leave Unit 1 behind and go out into the field to see how a road is actually located and surveyed. Until then, keep learning civil the easy way.